Hi everybody, today we're going to talk a little bit more in depth about polyatomic ions, and you might not know this, but it turns out that we have given you a list of polyatomic ions, but there are many others that exist beyond that. So when we head over to that list, you should take out this list as well, and you'll notice that I have underlined a bunch of things in red. And if you're really observant, you'll notice that everything I've underlined in red ends with ATE, and most of them do. So it turns out that most of these end with ATE, and almost all the ones that end with ATE, you'll notice the ion itself ends with the element oxygen. So that is important, the fact that all of those have an oxygen. Now there's an exception to this. It is right here, hexafluorosilicate. There's no oxygen here, so we're going to take this off our red list. There, it's gone. But for all these other ones that end with ATE, it turns out that we are going to give you this version. This version ends with ATE, and you are going to be able to apply a single set of rules to any of these ions to instantly make 3 more of every single one of those ions. So all of a sudden we have a huge arsenal of polyatomic ions at our disposal. So how does this work? Well, it turns out that if we add different prefixes and suffixes, we can change the number of oxygens in an ion. So we are just going to use chlorate as an example. This note guide uses chlorate, but notice that you can apply these same rules to any of these ones underlined in red, right? So you can apply it to anything that has the AT ending, and you can change them in the exact same way. Oops, excuse me. So here's the deal. If you would like to take your ATE version and you would like to give it an extra oxygen, you are going to add the prefix per. Notice that chlorate has 3 oxygens and perchlorate has 4 oxygens. If you would like to remove an oxygen, you're going to take your ATE version and you are going to change it to ITE. Chlorate has 3, chlorite has 2. And if you further like to remove an oxygen, you're going to keep that ITE form, but now you're going to add a prefix. You're going to add the prefix hypo. So hypo doesn't just take away 1 oxygen, it takes away 2. So now we started with 3 oxygens, now we are down to 1 oxygen. And this isn't really one of the rules, but some of you might wonder, well, what if I took away all of the oxygens? Well, all of the oxygens is just Cl- by itself, which is chlorine as an ion. Remember, anions get an IDE ending. Now, some of you might be getting clever and thinking, well, this is easy. I can just memorize that the prefix per always means 4 oxygens, and the suffix ate with no prefix always means 3 oxygens, and so on. But there's a problem with that. So let me show you another example here, and I'm going to select the polyatomic ion sulfate. So sulfate, let me write this here, sulfate is SO4 with a -2 charge. So now the kind of base unit of that ion has 4 oxygens, which means per sulfate, it's still the per adds an oxygen. So per sulfate still behaves the same as we saw on the right-hand side, but it doesn't now have 4 oxygens, it has 5 oxygens. Per sulfate is SO5 -2. Similarly, we can take away an oxygen, and we can still name that the same way. We can name it sulfite, ITE ending, and that's going to be SO3 -2. And we could also take away 2 oxygens, right? We could make hypo sulfite, and that would become SO2 2-. And some of you might be wondering, well, what the heck is SO -2? And to be honest, that's pretty unstable. It's something that doesn't exist because there's just not the right balance of charges between the S and the O. So we'll only ever ask you to operate in this zone where you're adding an oxygen, subtracting an oxygen, or subtracting 2 oxygens. But it's noteworthy that it's not always that the 8 form has 3 oxygens and then you can just memorize the pattern. Sometimes the 8 version has 4 oxygens or a different number of oxygens, and so you need to be kind of ready for that and ready to change in different ways. So really what we need to understand and learn is that per means plus an oxygen, ite means subtract 1, hypoite means subtract 2. Now there's another prefix that we can add that changes these polyatomic ions in different ways, and that prefix is twofold. The prefix can either be hydrogen or the prefix bi, and those mean the exact same thing. So, for instance, the prefix or the polyatomic ion bicarbonate or hydrogen carbonate is the same thing. In both cases, this means that we are going to add a hydrogen atom to the front of carbonate. However, hydrogen is H with a +1 charge. So if you take H with a +1 charge and you add it to carbonate, which is CO3 minus 2, you don't just get HCO3. You don't just get that. You get HCO3 with a -1 charge instead of -2 because you've taken this +1 and added it to the -2, which gives you -1. So bicarbonate or hydrogen carbonate is HCO3 with a -1 charge. And just so we're aware, sodium bicarbonate is baking soda. Okay, so let's apply these rules to the naming rules we've already learned and see what we can do. Let's first just attack these polyatomic ions. So fluorite. What's the first thing we should do? Well, we should talk about fluorate. So fluorate, if you look it up on your list, fluorate is one that we actually didn't give to you, my apologies, but fluorate is FO3. Fluorate is FO3 with a -1 charge. And you'll notice that follows suit with the other halogens. So chlorate is ClO3, bromate is BrO3, iodate is IO3. So it's not surprising that fluorate is FO3 -1. But we want fluorite. We want the version that has one less oxygen, so that is going to be FO2 with a -1 charge. Notice the charge never changes. Perbromate has this prefix per. What does that mean? Well, we've added an oxygen. Bromate by itself is BrO3 -1, so perbromate must be BrO4 -1. Manganite. Well, if we had a manganate, that would be really easy, but we don't. It turns out the most common form of this ion is permanganate, and permanganate is MnO4 with a -1 charge. So if permanganate is MnO4 with a -1 charge, that must mean manganate is MnO3 with a -1 charge, which means manganite is MnO2 with a -1 charge. And let's just box this in for clarity. Hypoiodite, right? Prefix hypo, suffix ite means we subtracted 2 oxygens from the 8 form. So if the 8 form of iodate is IO3 -1, if we get rid of 2 of those oxygens, we are left with IO with a -1 charge. Biphosphite, well, now we got a lot of stuff going on, right? So let's step through this thing. First off, phosphite with an IT ending means we took phosphate and we subtract an oxygen. So phosphate, if you look it up, is PO4 -3. Phosphite then is PO3 -3. But if it's biphosphite, the bi means we're adding in a hydrogen, and remember hydrogen carries a +1 charge. So if we add all of that together, biphosphite is HPO3, but now with a -2 charge because the +1 and the -3 went together. Okay, let's try going the other way. So let's look at these polyatomic ions and name them. So we have HSO4. As soon as you see a polyatomic ion starting with an H, you want to write in the prefix bi or the prefix hydrogen. Then you figure out what SO4 is. If you look on your list, you'll see that SO4 is there, and SO4 is sulfate. So this must be bisulfate. Another possibility would be to write out the words hydrogen sulfate. They mean the same thing. We would accept either one if we had a graded assessment. Looking at BrO3 minus, well, BrO3 minus is on your list already. This is just straight up bromate. Nothing to see there. O minus 2. You might look at your list and see something similar, and it might look like this, right? O2 minus 2. And here's the danger that a lot of people want to do. They want to say, well, okay, O2 minus 2, this is peroxide. And so a lot of people, for whatever reason, think, well, I'm getting rid of an oxygen, I'm going to make it oxite. But actually, that's not the case. Really, what we have going on here is we have oxygen by itself. Remember, single ions, single anions like this, are simply the name of the element, which is oxygen. But you sub out the ending for the letters IDE. So any single anion, negatively charged ion, simply is an IDE ending after the root word of the element. Let's look at NO minus. NO looks like a polyatomic ion on your list, which is NO3. NO3, you'll notice, is nitrate. If NO3 is nitrate, that means NO2 is nitrite. We have NO1, so NO1 then is hyponitrite. And finally, CrO5 minus 2. That looks a lot like something on your list, which is CrO4 minus 2. CrO4 minus 2 is chromate. So if we want to add an oxygen, then this must be perchromate. And finally, we can use these new rules in naming. So let's look at two examples, KClO2. Well, let's remember the order that we do things, right? First, we need to name our anion. So ClO2. ClO2 looks a lot like the polyatomic ion ClO3, which is on our list. ClO3 is chlorate. This is ClO2, so that means that this is chlorite. Next step in our rules is to look to the cation and ask ourselves, does this need a Roman numeral? Potassium is in the first column. It's always a +1, so no, it does not need a Roman numeral. It's always just potassium. So our new name here is potassium chlorite. Looking down to number 12, again, ClO4 looks a lot like ClO3. ClO3 is chlorate. We've added an oxygen, so this must be perchlorate. And then our cation, does this need a Roman numeral? Well, no, it's actually just a special case. It's a polyatomic ion cation, and we have a name for it, which is ammonium. So we are looking there at ammonium perchlorate.